Now, I got to tell you first about number 5. I made a little typo on this sheet. It technically doesn't matter because you could switch these anyway since it's multiplication, but I did not intend for that to happen. I intended for this pi over 12 to be right here and that 5 pi over 12 to be right there. Okay, so before you start trying to understand this problem, just know that. But first of all, looking at the formulas, it says cosine times cosine plus sine times sine. So if we go up here, this is the formula we will be using, and you can see highlighted we have alpha, alpha, alpha. All of those first locations are alpha, and then beta is in the second locations there. Well, what are we supposed to do? We're supposed to take cosine of alpha minus beta. So I'll scroll back up in a second, but basically that means you take cosine of alpha, which is pi over 12 for our problem, minus beta, which is 5 pi over 12. So we're actually like going backwards on this. I know you guys want to break these up and you want to use your formulas to find the value, but we don't have a reference triangle that we've talked about for pi over 12 or 5 pi over 12. So you can't go draw those diagrams and get those ratios. So we have to go the other way. Well, think about this. If I do cosine of, and I put that together, that's going to be negative 4 pi over 12. Okay, now let me back up a second. Again, how did I get there? I was using this formula right here. Cosine of alpha minus beta. Well, your problem had a pi over 12 right here and a 5 pi over 12 right there. So we do pi over 12 minus 5 pi over 12, which I currently just made negative 4 pi over 12. So basically that puts us at cosine, excuse me, reduced as negative pi over 3. All right, so now I know where that's at. That's a 60-degree angle down this way. So I throw my 60 in there, got my root 3, which is negative, got my 1, which is positive, and my 2, and cosine of that would be 1 over 2, boom, 1/2 is my final answer. Okay, so all in radians, just knowing how to use that formula the other way. Some of these are easier. I mean, let me scroll up here and do, since you can see both of them, like number 3 here has cosine cosine minus sine sine. Well, oh, that's this one right here. If you look, I'm not looking at the left side right now, I'm looking at the right. Cosine cosine minus sine sine. Well, that means that's equivalent to taking cosine of, and then just adding those two angles together. So like you're going backwards from how we first learned this. So 70 plus 20 is 90. So cosine of 90, well, that's the cosine of the quadrantal there, which we all know is 0. So the answer to that one's 0. One like number 2, I'll do one more here and cap this video. I can do addition, I can do subtraction. Most of you probably won't want to do addition to this one because you'd have to use a negative. So I'll probably see most of you, picking, you just kind of spell it out here, picking 2 different angles that we can subtract and equal 15, but we have to know what those are. So obviously like 30 minus 15, bad choice. We don't have 15 as a reference angle. 45 and 30, okay, that's good. That has a 15. So if I put a 45 right here and a 30 right there, that is the same as 15 degrees. Well, again, I have cosine of alpha minus beta, so I'm going to use that formula this time, just differently than the way I just discussed it a minute ago. So what we got to do is take cosine alpha. Well, here we go. I will draw a couple reference triangles. Some of you need this still. A lot of you do. Some of you can do this in your head, and that's great. But that's 1, 1, 1 root 2 for this one. And then we got our 30, which would be 1, 1 root 3, and 2. So here we go. Cosine of the first one is 1 over root 2. Literally just doing cosine of this times cosine of the second diagram there, which would be root 3 over 2. Formula tells me to add, so I add. And now I do sine of my first diagram there, which is 1 over root 2. And I multiply by sine of the second diagram, which is 1 over 2. So that's equivalent to, we have a common denominator, so we can put it all together. We got root 3 plus 1 all over 2 root 2. Okay, so just a couple of notes here. How would I break up 7 pi over 12? You got to think of 2 radians that we would either add together or subtract to get equivalent to that. Same with this one. I will actually, actually 6 is a little unique. I want to talk about this one. I think this one's kind of cool. I know it says secant, But a little extension, if you know what cosine is, then you should be able to figure out what secant is. So you can think of this as cosine, and then just remember at the end of the problem to take the reciprocal of that, and that would give you secant. Well, I know 165 is still kind of goofy for some of you, but if you look at 135 plus 30, that actually is equivalent to 165. So here's what I'm not going to do. I'm actually not going to finish this video. That has cosine of alpha plus beta. So we're going to use our formula up here. You would actually use that first one up here, and you would get your answer. And then after you do your work and you have cosine, just take the reciprocal. Okay, so whatever your answer is, the reciprocal is going to be the answer for secant. Check my answer key. You'll see if you got it correct.